In today's episode, we're going to take a look at the hardware that's required in order to build a fictitious customer network in the year 2005. And then we're going to throw together some stuff so that we can get a fake ISP running as well. And if we're lucky, I'll be able to do all of this in a way that matches the network diagrams that I've created for our infrastructure. I'm Josh, your host, and this is Tech Tides. Welcome back to Collaborate Like It's 2005, a video series where we bring mid-2000s enterprise collaboration back to life. We're diving into the gear, the software, the protocols, and the experience of running CallManager 4.13, Cisco Unity Express, CallManager Express, and more using at least some authentic hardware from the era. Whether you lived through that time or whether you're just curious to see what it was like, this is your time machine. In this episode, we're going to be getting our hands dirty with the physical lab itself. We'll walk through every component in the rack, explain its place in the collaboration stack, and then we'll power everything on and get things connected. This is our lab, split into two roles. On the ISP side, we have our ISP, Nexion. Nexion's powered by a Cisco ISR 4451X, and inside of that is a UCS Express module. This simulates what we would today call the cloud. Basically what passed for that is in 2005 anyway. And then on this side, we have our customer network, Pinnacle Dataworks. At their core, a Cisco 3825 integrated services router, and that's paired with a Catalyst 3524 switch and a UCS C220 M3 server. Now, the server doesn't quite fit the time frame, but our alternative was using multiple servers, and I would rather virtualize these services. So this is what we're going with. Not quite era appropriate, but we'll focus on the software for that part of it. So now we're going to walk through both sides, both networks in detail. Let's start by taking a look at our fake ISP, who I'm calling Nexion. Now, for Nexion, I'm going to be using this router. This isn't quite the period I was looking for here. This router, the Cisco ISR, Integrated Services Router 4451X. This router was first announced on June 24th, 2013, and was to start shipping in July of 2013. So a bit newer than the rest of our network. I had originally intended on using a 3845 router as our ISP router, but it's already 3 rack units tall, and I was going to need some compute as well. The advantage with using this router is I can actually put a compute module in one of these slots, so I'll show you that in just a minute actually. Now this particular router has 4 gigabit interfaces, and those interfaces can use either SFPs or copper, and then it has 3 of these NIM slots. Those are network interface module slots, and we can put a wide number of cards in these. And then it also has 2 of these SM slots. And an SM is a service module slot. So we'll go through a couple things here. Let's take a look inside of the router next. Go. Okay. Inside the router, over here we've got our DIMM slots. In this router, the 4400 series routers, there's actually 3 DIMM slots. There's 2 DIMMs on this side. These are for control plane memory, and then this third one over here is for data plane memory. And I'm not intimately familiar with how exactly that works. All I know is they all have to be the same size. I believe these are all 2 gigabyte DIMMs in this unit, if I remember correctly. Over here, it's kind of hard to see. Right here, there's a little square module that's been added on. That is a PVDM4 module. Now, the PVDM module stands for Packet Voice Digital Signal Processor Module. Now the PVDM is used for voice services. So this can either be used for voice T1s for PRIs and CAS T1s. It can also be used for other voice services on the router. So it can be used for things like transcoding or MTP media termination point. It can be used for conference bridges. So any kind of voice resources that you might need on a router, that's what a PVDM can be used for. And then over here, you can kind of see, it's really hard to see here, there's a spot for a PoE, a Power over Ethernet module, that can actually feed these first two ports here, gig 000 and 001. Those ports can actually be PoE ports, but you have to have an additional module here in order for that to actually be functional. So that module is missing from this unit. I think that's pretty much everything in terms of the internals here. So let's button this back up and then we'll move on to some of the modules we're going to put into this router. So first thing we're going to put into this router is a MIM module. So we're going to take off one of these blanks here. And the module we're going to put in here is see if I can get it close enough to see here. It is a 4MFT T1E1 module. So this module provides up to 4 T1 interfaces, and this is an MFT interface, or multiflex trunk. So these T1s can either be voice or data T1s. Oh, and I forgot to show, this module also has a PVDM built into it. It's kind of hard to see here, but there's a square PVDM module that actually clips on here as well. And again, I'm using that because we're going to be using voice services. Now, I misspoke earlier. I said the PVDM inside of the router could be used for T1 interfaces. That actually used to be the case on Cisco's old routers. On these new routers, if you want to use a voice T1, you actually have to have a PVDM present on the interface itself. So having the module present in the chassis does not work for voice T1s. The module has to be here. So in this case, we've got both. Doesn't really matter. I've got a couple extras anyway, so we'll use both. Okay, so we'll get this interface installed here. Now the next module we're going to install is this guy. This is a UCS Express server. So this is a UCS-EN 120S-M2. So this is a second generation UCS Express module. We'll go over the exact specs of this. I don't fully remember what we've got here. These are 8 gig DIMMs, I know that much. So it's got 16 gigs of memory on it, and it's got a low-end Xeon processor. So we can look at that when we get this thing operational. So we'll remove this blank for this first service module here. And then we will install this server module right over here, and then we'll close these captive screws to lock that in place. And then in terms for hardware for this part of the process, for our fake ISP Nexion, that does it. So this will give us enough capability to kind of get our first customer online here, our first fake customer anyway, and then from there we'll see if we need to add things down the road, but this works for now. So now let's take a look at the actual customer hardware we're going to be using today. Next up is the hardware for our customer network. My fake customer, Pinnacle Dataworks. And what we're going to be using for our router here is a Cisco 3825. This is considered a first generation ISR, Integrated Services Router by Cisco. And this router has 4 WIC slots, or actually they are HWIC slots, which stands for High Speed Interface Card. So up to 4 of those can be installed here. And then although it appears that there are 3 network module or NM slots here, there's actually only 1 single wide slot, and then there's a second. So if you can see the number down here, that's 1. This is 2, and Network module 2 can either be a single wide slot, or this center divider can be removed and you can put a double wide module in here. This would be like if you wanted to have a switching module inside of your router, you could put a full width switching module right in here. This router also has 2 gigabit Ethernet interfaces. One of those can be used either copper or fiber, and then the other one is copper only. So now we're going to take a look inside of this one as well. Unfortunately, this one's significantly more complicated because we have to disassemble a lot of pieces here. So we'll do that now. Start by taking off the rack ears. And then there's 2 screws here at the back on the top. One screw at the front. And then there are an additional 3 screws on each side. Okay, now we got all those removed, we should be able to push this case forward. There we go. And then we are greeted by even more stuff to kind of limit our view here. So next we have to remove this power supply. So let's make a little room here. Actually turn this around. Okay. Remove the power connector. These are captive thumb screws, but these tend to be pretty tight, so I generally use a screwdriver here. And once we've done that, this, in theory, will lift out of here. Okay, there we go. Okay, so now, inside of this router, we can see right here, there are 2 DRAM slots. This particular router only has one of them populated. I can't remember what's in there. 256 megs maybe. I don't recall. We can look when we get in the software later. And then down here in the bottom, again we see PVDM. So there's 4 PVDM slots here. 2 of them are populated by PVDM2 64 interfaces. So that's 64 DSP resources on each one. These are PVDM2s, which means they're 2nd gen PVDMs. In the ISR 4000 we looked at later, those are PVDM4s. So those are 4th gen PVDM modules. The MFT T1 interface we looked at was also a 4th gen MFT T1 interface. And then back here, of course, we have our compact flash card as well. So I think that pretty much does it for the customer router. I don't think there's anything else super exciting to show you here. Oh, there are 2 additional modules here that are not populated. You can see those here and here. These are AIM modules, AIM0 and AIM1. The AIM slots can be used for VPN modules, Cisco Unity Express for voicemail. There's a few different things you can get. AIM stands for Advanced Integration Module. So there's additional modules there if you want to add that kind of capability. So let me go ahead and get this put back together, and then we'll move on to the next piece of equipment for Pinnacle Dataworks network. I almost completely forgot, before we move on to our next device, we need to add one more thing to this router, and that's a network module. The network module we're going to be adding is this guy, and this is an NM HDV2 2T1E1. So this is a high density voice module, and we talked about PVDMs before. This one also supports PVDMs, so there's up to 4 PVDMs on here. So again, I've got a PVDM 264 on here. Now the way this works is each T1 interface is 24 channels of a PVDM. So if you're using these as both T1s here, you would need a total of 48 channels. And since this is a PVDM 264, this is 64 channels, so there's plenty of capacity there. Now we could potentially put in an additional 2 T1 MFT card, in which case we would need more PVDMs to support those if we were going to do voice on all of those. Now the alternative here, and what I think I'm going to do still, these onboard HWIC slots can also take MFT cards, and since I've got PVDMs on board, that's actually my preference. However, the router that I have, the iOS router combination, doesn't actually support the second generation MFT modules. Now some of the documentation that I've seen says that it should, but for whatever reason it shows as not supported. It gives a message about being not supported in the slot or whatever. So I've ordered a first generation MFT card. That would be a VWIC 2 MFT T1. The first gen MFT cards were not T1E1 interchangeable. They were only one or the other. And these are the cards that I have right now. These are VWIC 2 MFT T1E1 modules. WICs, VICs is actually what they are. So once I get that, I'll be trying that out in here as well to see if I can free up a slot so that I don't have to use the HDV module. So, but for now, we'll put in the HDV module. That way I can get the PRI up and running, and we can get voice calls going between our ISP and our customer site. Okay, there we go. We are now voice ready on this router. I forgot to mention this router, the 3825, along with the 1800 series, the 2800 series, and its big brother, the 3845. These routers all launched in the year 2004. They were first announced September 14th, 2004, and then they were expected to be available for purchase in October of 2004. So that kind of fits with our theme of collaboration in 2005. This was late in the year 2004, so if you were building a new network in 2005, you were definitely probably looking at something like this. All right, now for our customer switch. This is the Cisco Catalyst 3500 series XL inline power switch. So this switch supported Cisco's pre-standard power over Ethernet, which they called inline power. So this was at a point in the industry when there was no standard for PoE, for power over Ethernet, and Cisco needed a solution to power its phones, and right around this time they had wireless access points that also needed a solution. So Cisco needed a way to power things, and instead of waiting for the industry to ratify a standard, Cisco just built something, and so that's the inline power standard that they built. This particular switch was actually announced November 12th, 2002, so we're a little bit older than I was looking for here. Actually ordered an upgrade for this, so if I get that in, then I'll cover that as well. And then this switch was expected to start shipping in December of 2002. So still potentially an option if you are buying a switch, but you would probably be looking at something a little bit newer. There was a 3560 power, inline power, and standard power, so 802.3 AF PoE switch. The 3560 version of that released in the year 2004 as well. So if I get that in, we'll talk about that. This particular switch has a couple of GBIC modules already in it. It seems like when you buy these used, most of them are populated with something. Don't know, not tested these, not sure if they work or not. This is a 1 gig, 1000 base SX fiber GBIC. So maybe we'll play with that at some point, maybe not. And then on the back here, We don't have anything too exciting. Power connector. These switches did support a remote power supply and RPS, so there's a connector for that. You could get redundant power out of these switches. And then of course we have our console port. And then right here we see our exact model number. This was a WS C3524-PWR-XL-EN. So this is one of the devices we'll be going through and configuring to set up our Pinnacle Dataworks network. Now we'll move on to our last major piece of hardware for this network, and I'll be right back with that. This is the final piece of our Pinnacle Dataworks customer network. Now, this is a Cisco UCS server. Specifically, it's a UCS C220 M3. Now, this server is quite a ways outside of the time frame of our customer network. This server was announced on March 8th, 2012, and it was the third generation of UCS server. The first generation UCS server from Cisco actually launched in 2009, so even that would be fairly late considering our 2005 era network here. Now, the reason I chose something like this is because I don't have a ton of rack space right now, and servers of the 2005 era generally were not virtualized or really even virtualizable. That year, I believe, or that year, the year before, the year after, somewhere in that time frame is when Intel launched their first dual-core Xeon processors. So trying to virtualize something even on a dual core system that gives you 4 cores doesn't really give you a lot of headroom for VMs of that era. So theoretically, even if you did 4 single core VMs, you could potentially get 4 VMs on a server if you had that kind of a setup. Now you could get a little more crazy with a blade server, something like that, but again, I'm space constrained, and cooling can be a challenge for me when it gets really hot out as well. So ultimately that's why I chose this. In here we've got a couple of SAS disks just as our boot drives. I don't care as much about performance on those. And then I've got 4 480 gig solid state drives just for my VM storage. So those are in a RAID 5 array. And then I've got a couple of empty spots here just in case I need to add something. We'll take a quick look in here. Don't know if there's anything super exciting. We've got to loosen a thumb screw back here. There we go. Not a big fan of the M3 lids. They're very hard to remove. Okay, so this is really hard to see, but let's see if we can move this up a little bit. So these are our dual Xeon processors. I don't have the exact specs. We can look at it when we get into this. And then I've got this fully populated with memory. Again, I don't remember. I think there's 256 gigs of memory in here, so should be plenty for whatever we're trying to run. Back here we've got different network adapters. The only thing that's in here right now is a SAS controller for the drives. Other than that, pretty much empty. And then I've got dual power supplies in this unit. So I think that's pretty much it for our server. This one does have a battery backed RAID controller, so that's nice. We don't have to worry too much about power outages. Yeah, I think that's it. I don't think I really have anything else super exciting to show you here. So we'll get this closed back up, and then that should be it. I may give you a quick glance at the phones that I'm going to be using, but other than that, we should be almost done with our hardware tour here. You know, I've got this here. I may as well show you guys the back of it real quick, just in case you're curious. Okay, so again, power supplies over here. We've got a half height PCI Express card here, full height PCI Express card here, which I just realized I'm missing a blanking plate for. And then down here we've got a pair of gigabit NICs on board for connectivity. Here we've got a dedicated management interface. So Cisco uses something called the CIMC, the Cisco Integrated Management Controller, I believe is what that stands for. And then here we've got a serial port. I believe that's used for general management of the server, and of course a VGA port. Somewhere right over here there's a couple of USB ports as well. So that's pretty much it. Nothing super exciting here. So we'll get this wrapped up, and I'll see you next with the phones. Okay, so finally we have the phones. Now this is probably one of Cisco's more iconic phones. The series anyway. This is a 7940. November 28th, 2000 is when this phone was announced. So it's been around a while. A little bit older than kind of what we're targeting, but definitely something that you might have owned in 2005 just because of their popularity, their availability. Super popular phone. Here we have a 7912. Now the 7912 was announced on April 28th, 2003, so a little bit closer to our time frame, our 2005 collaboration solution time frame. I do have a few of these. I might be using these a bit more, but definitely these are fairly well known for the era. So these are some of the devices I'll be using. I'll also be using IP communicator for testing, some other solutions as well. So hopefully we'll be able to demonstrate by the end of this process. Phones calling between these two and showing everything up and running. Okay, so that's a look at all the hardware we're going to be working with. So I'm going to run downstairs and get all that stuff put in the rack, and then I'll give you a quick tour of how that's all organized, and we'll connect everything together. Okay, set up the network rack here. So here at the top, we've got our ISP router, our Nexion router, and then I've got this octal cable coming off of this async module here. All these green cables, those are for serial access. So we're just going to start at 0. We're going to start by connecting these up. We're going to connect this P0 into our Nexion router console port here. Sorry, a bunch of stuff in the way. It's a mess in here. And then next we're going to do P1. P1 is the next one down. The way I've got this rack, my switch is next. So no specific reason, but I'm going to go ahead and plug that in the back there. That's where that one goes for that switch. And then our next one is for our customer router, the 3825. That's for Pinnacle Dataworks. So we'll plug in P2 into that console. Okay, good. So now the next thing we want to do is go ahead and plug in our T1 interface. Now there's some existing configs on here that I did for testing, so assuming I plug this in the right way, this should actually work. So this is I can show you this pin out later, this is a T1 crossover cable. So we're going from port 0, P0 on this MFT, 4th gen MFT card here, down to port 0 on our HDD interface. So, and we can see here that the alarm, the amber light there cleared. So that T1 should be up. Okay, so next, let's connect, based on our Visio diagram, let's see. This cable goes to my dedicated management switch here. So we're going to plug that into the SIMC port on our UCS Express module. So we'll do that. This one is my actual primary lab network. So we're going to connect that over here to the Gig E2 interface here so I can get to that from my home network. Alright, and then next we want to, what are we going to do here? We're going to take this cord, this goes to my main network. So this is a layer 3 handoff that I've got static routes set to. So according to our diagram, that goes here to Gigi 003, and then that should come up. Okay, good. And then the next thing we're going to connect is GIG-000 on our Nexion router. That's going to go down to our customer router, and that's going to go here to, let's see, on our diagram, I believe that goes to GIG-000, I think. And then we'll go from GIG-E01, oops, right there. That's going to go to port 24 on our Catalyst switch here. Okay, good. And then this cable, we'll show the UCS server in a minute. This comes from one of our UCS server interfaces. We're going to plug that there into port 1. And I think that's all of our infrastructure connected. So now let me get our phones set up here and we'll plug them in. Okay, excellent. So here are 3 customer phones, and we're just going to pick arbitrary interfaces. These are actually all configured the same, so it really doesn't matter. So we're going to do 10, 11, and 12 here. You can see these guys getting power as we plug them in, so that's good. And then I do have one other phone that's sitting just over here in the corner. We're going to plug that in as well. That actually goes to Nexion, our ISP. So we'll hook that in here just to kind of indicate to ourselves that it's different. And that should be all of our connections on this side. And let's go take a look at the UCS server here. Okay, so lighting is not great back here, but here's the back of our UCS server. So in port 2, we're going to connect the link up to our Catalyst switch, our customer switch. Link 1, this one goes to my home lab network, so I can get to this if I need to. And then the SIM-C port here, the management port, we plug in there, that's for SIM-C access. So that should complete our connections here, and we can start to get into the software side of things. Well, I had originally intended to do more, but we've already passed the 30-minute mark, and I'm trying to keep these videos somewhere close to that. So we'll finish up with some testing here. This is kind of a finished configuration. So we'll walk through this all in future episodes, but just to kind of give you a teaser for those. We're right now in the Nexion router, so take a look here and confirm this is our 4451X, and we'll just check a few things here. So if we do show ISDN stat, we can see we are multiple frame established. So if you're familiar with ISDN at all, you'll know that that means that the PRI is up. So that's a good sign there. We're going to look at show CDP neighbor as well. So we can see Pinnacle Dataworks, sorry, is here. We see them setting off of GIG-000. We see a 3825. And we see some of my other infrastructure here as well. So that's looking good. From our diagram, we know that we should be able to reach that router. Actually, let's just do this. We'll do gig-000 detail. Let's see what we get for an IP address. Yep, that'll work. So if we take that, we should be able to ping that. That's looking good. Okay. And we also know, we'll just go ahead and just telnet into that. All right, good. So there's our Pinnacle router. Now, normally you would have CDP LLDP disabled between your ISP and your customer, but you know, this is my environment, so I'm going to do it the way I want. So here we are in Pinnacle router, and again we can see the Nexion router. We can see our Pinnacle switch there as well. That's our 3524. So again, we should be able to go 1.1 detail. And we're getting this IP address, so that's good. We should be able to ping that, and we can. Okay, so let's telnet into that. Oh, one other thing. Let's go back here. Whoops. That's a no-no. I always should disable that, and I didn't. Okay, show ISD and stat. Excellent. So multiple frame established on this side as well. One thing you'll see different on this side, you'll see Q931 is backhauled to CallManager. So this router is already registered to CallManager. It's up and operational. Again, we'll go through all of that in a future episode. So, all right, back into the switch, show CDP neighbor. We can see a few phones in here. Let's see. We see they've got an IP address, so that's good. We see our CallManager server here on Fast01. So take a look at that. We see platform Windows 2000 server, so there you go, stuff that Cisco adds to the mix there. So far this is all looking pretty good. Let's double check this. Everything's looking good there. So we're in pretty good shape here. So what we'll do next time is we'll kind of cover all of the base configurations that we can, and then we'll move on. We'll continue working through this lab till we can demonstrate everything fully operational. Before we wrap up, I figured I would show one more thing. Here's our two hosts. This is our UCS C220 M3 server here. Right now I've just got a domain controller and our CallManager server on there. We'll take a look at those in just a second. Here's our other UCS Express box that's sitting in our ISO 4451. So again, right now there's two VMs on there. One is our Web 1 proxy server, and we'll cover that in the future, as well as the virtual Cisco Unity Express that we'll talk about later as well. Figured I would show this as well. This is our CallManager server. We'll go ahead and log in here, and I'll show you that these phones are up and registered here. So we can see there's 5 phones configured, and these last 2 are just soft phones. But these 3 are regular desk phones. There's a 7912 and 2 7940s. You can click right on these links to get to the web interface of the phone as well. So those are all up and working as expected. The other thing we can look at too is the gateway here. So we will go in here, we'll click endpoints, and then we can see that this gateway, this is the PRI that I was showing you, is backhauled to CallManager. That's what this is. So that's registered to CallManager, and that's the IP address of one of the interfaces on that router. So that all is working as expected, and we'll talk more about this in a future episode. One other thing that I thought I would show here is I've got CallManager Express set up on the Nexion router, and so if we look at show ePhone, we can see that there's configured devices. This particular device is responding, so that's one of my phones. That is a 7912, and yeah, so that's CallManager Express is working, CallManager is working, Unity Express is working. It's attached to this Nexion router as well. So again, we'll go through all that in future episodes. So there we go. We've started our collaboration journey, our 2005 collaboration journey. We're well on our way. Next time the goal will be to do some configurations, some device level configurations. So time permitting, we'll jump into the Nexion router configs. I'll be wiping that device out. We'll configure it from the ground up. And we'll be doing the iOS configs. We'll configure CME, CUE. We'll set up the Web 1 proxy. We may load VMware on it. I may redo that part as well. What do you think? What would you like to see me do next? What should I add or change from this environment? Let me know your thoughts in the comments. I appreciate your feedback. Until next time, this is Josh.